All right, let's do this problem. This is an implicit differentiation problem here. So let's see. The curve is y cubed minus xy squared equals 4. And we got to find the slope of the curve at the point where y equals 2. So the slope of the curve is the derivative. Now we got to use implicit differentiation here because I've got x's and y's all tangled up. So we're going to take the derivative with respect to y. I'm sorry, with respect to x. So again, we go term by term. So actually, I think, let me just write it like this. So we're going to take the derivative of y cubed, and the derivative is summative. I'm going to treat this subtract as a subtraction symbol. I'm going to leave it there. And now I'm going to take the derivative of xy squared, and then on the other side is the derivative of 4. Okay, so now what do we got? Let's start with the easy side. So the right side is 0, because that's a constant. The derivative of y cubed is 3y squared, and then remember we multiply by dy dx afterwards. Minus, and now here I got to use the product rule, right? So like if I think of that as f and g, then my product rule, just jotting it up here again, it would be f prime g plus f g prime. That would work. So it's minus. Now you gotta set yourself up for some terms that are going to be added together. So f prime is the derivative of x, which is 1, and then g is just y squared, plus f g prime. So f is x, g prime is the derivative of y squared, so that's 2y, and we took the derivative of a y term, so follow it up with a dy dx. Now, here's like the thing. So we can clean it up a little bit. 3y squared times dy dx minus y squared, if I distribute. And then this becomes a minus 2xy times dy dx. And that's equal to 0. So the thing with this problem is, like, we want dy dx at a moment when x is equal to 2, or y is equal to 2. That'll let us fill in the y values in this equation, but what about that x value, right? That has to turn into a number. And so what I need to do is I got to find the x coordinate on the curve when y is equal to 2, right? So again, I'll just jot down my equation again. It was y cubed minus xy squared is equal to 4. And when y is 2, what's x? So when y is equal to 2, x equals, because we need that, like we're going to have to, our derivative up here is going to be in terms of the x and y coordinates. So we'll just put a 2 in for y. So that becomes 2 cubed minus x times 2 squared is equal to 4, or 8 minus 4x is equal to 4, which means negative 4x is equal to negative 4, so x is equal to 1. And now what we can do is plug those in. And so we can plug them in right now. We don't have to solve for dy dx in terms of the other variables. We are welcome, since this is a multiple choice and we need a value, let's just plug in x equals 1 and y equals 2, and then solve for dy dx. Okay, so that becomes 3 times 2 squared times dy dx minus 2 squared minus 2 times x is 1, y is a 2 times dy dx. All that equals 0. So this becomes 12 dy dx minus 4 dy dx is equal to 0. I'm going to add 4 to both sides. And so I'll get, and then I'm going to collect, these are like terms, right? I have 12 dy dx's minus 4, so I have 8 dy dx's on the left, and on the right I have a 4. And divide both sides by 8, and you get 4/8 or 1/2. So that answer choice should have been D.